All right, we're going to go ahead and get started. My name is Tanya Jackson, Vice President of Operations for Montrose Air Quality Services and the moderator for this room. Our next presentation is by Roy Massengale from EnRUD. It'll be on proposed Quad OOOOb and Quad OOOOC LDAR and equipment requirements, updates, and changes. Roy Massengale, air emissions testing upstream to downstream with locations in Fort Collins, Colorado, Tulsa, Oklahoma, Billings, Montana, Midland, Texas, Corpus Christi, Texas, and Houston, Texas. EnRUD provides source testing, mobile laboratories, and personnel to provide industry the sampling and compliance source testing required for many emission points, including compressor engines, turbines, boilers, heaters, flares, process vents, LDAR, traditional LDAR programs, IR camera inspections, high flow sampler testing and studies, component counts, greenhouse gas programs, field service, and mobile inspection software with legacy system integration. Please, everyone, welcome Roy.
Yeah, that bio was really a marketing. But want to get on with that. We talked today on the changes to Quad OOOOb. I gave a similar talk last year, which was Quad OOOOb, Quad OOOOC. So changes basically are, old pads are quarterly, and we got some periodic alternative monitoring, and reciprocating engine now require GHG type testing. That could be the summary of this, right? I put together for my company, I have to train technicians, right? So I go through and I build content. This content is boring, right? But we have to train on it. We have to introduce these to them and find some bright-eyed, bushy-tailed person who wants to learn it and provide him information. This presentation is basically a cut and paste from that. So I have citations and everywhere. It's too much information, but then I have tables which summarize it. I'll skip over parts of it because it's just too deep for this particular, group. But if you ever have to write a plan, if you ever, like for the reciprocating engine, when you got to do the rod packing testing, right? Well, it's no longer the old GHG. So we may have to write a plan. I got that broken down with citations that you can, we all like to cut and paste and maybe figure out how to write the plan. So this can be used not just for, information now and introducing that, but it may, if you download it from the website or wherever they had these at one point, it could speed up some things if you like what you see, right? Or else you can do it on your own. But it's just could be a shortcut. So I'm going to be trying to after lunch make a regulatory talk interesting, or at least have you not fall asleep. Okay, so I'll be going through things fast. Ain't no need to get there and hem and haw about certain things. We'll hit on the high points. I'll be giving my opinion a lot. Okay, whether it be on philosophically what you should be doing, how I feel about the rule, what I think the EPA is going to do. I've been doing this for 33 years, so I feel I can give an opinion. It, like I said, it's an opinion. Take it for what it is. Agree with it, disagree with it. But if you do, this is very interactive. I want it to be. Sometimes work in a vacuum in rules. So if you disagree, afterwards I'll leave enough time to give your opinion. I'd love that because, problems are solved sometimes by confrontation, and it's only confrontation in the delivery. So tell me if you have a difference in opinion, right? And because I could be wrong and have been wrong before. So, and anytime you go through a reg, New Mexico rule, Colorado state rules, federal rules, and things like that, you got to start from a structure of the rule. You want to try to follow the rule because that's where people are going to be referencing what you say, and that's how they go through it. So here's, it has all these source categories, compressors, pneumatics, etc. In red is what I'm going to talk about. I'm going to be focusing on LDAR type of facilities, mentioning briefly some of the other ones when I feel comfortable doing that. I'm not a storage tank expert. I'm not a KD person, so I won't be talking anything about it except going to control, that type of thing. So the ones in red are the ones that I'll be really spending a lot of time on, staying away from well completions. I'm not in production. So those are the type of things how this is going to be focused on. And you can see all the different things on the rule itself. And I'll be handling the changes in the gas plant rule, the notorious Appendix K. This is not a talk on Appendix K. Okay, but I will give my opinions on Appendix K throughout this talk. First thing is, are you subject to it? We got several source categories. Once again, in red is ones I'm going to handle. Pneumatic controllers, you need to be going compressed air. So if you're not on compressed air and you ain't got access to grid, you probably need to go that way if you're not already there. Like I said, I'm not going to be talking about tanks. This used to be gas plants. Now they call it effective. See, I got a pointer. Now they call it unit effective facility. The big one, the fugitive emission, the super emitter, that's sort of different. We haven't ever really addressed that before. GPA, the production facilities were all in Washington a couple, I think the week of the 20th, talking about that, complaining about that. So we don't know what's going to happen. Industry is against it. To me, it's a super emitter, my opinion. I mean, why fight about a super emitter? I mean, it's 3, 4, 18 standard deviations outside the norm. Should be. But there are legal ramifications they're concerned about if other people are allowed to look at them. So as I think about it like that, they're looking at it that in the future, they may be legally required to do something, but it's still a super emitter. These are things we're concerned with. See if I hit everything. Reciprocating compressors, that's the same as Quado. We got some changes on that. Want to pay attention to that, especially if you're in the LDAR community, because there's a chance to, once again, do GHG type testing more of a periodic basis on a larger group of components, a group of compressors. When must you comply? Well, it hadn't been published yet, okay? And I have another slide later, but basically 2 days after it's published, there's a that's when you're subject to the subpart, right? There are some different timings for the way gas plants, it still mentions 180 days, which was a gray area a few years ago. And reciprocating, they have a different compliance timeframe for reciprocating compressors as an affected facility. I'll be talking about reciprocating compressors once again. I'll be talking about them in more of a timeframe of the annual inspection that's required that is similar to the GHG testing. Okay. Remember back when we had KK, DB, BBA, and you could be in the same gas plant. You could be under both of them. That unit's hadn't been modified, right? So it was under triple K or just DB, and then this one over here because it was modified later. But only that part of the plant was under BBA. So one had a 10,000 BPM, 500 leak deflection. One we had two connectors, the other one we didn't. We're running into a similar situation. Not that I would do it like that if I was a facility. I just do everything quarterly when we get to that point. But this table breaks it up as far as when that facility was constructed, what you may fall under. I want to do that with the caveat that if you are a oil production, we're basically talking upstream, you don't want 28 facilities that are semi-annual, 28 that are, I'll say quarterly, right? And then you got to keep track of that. And then your operations people go out there and, recomplete a well or do something for a modification. You got to keep up with it. So depending on the economics, pick one is how I would run the program. And that's not self-serving just because I'm an LDAR company and I want it to be quarterly over semi-annual. It's protection for compliance. You decide the economics of that. And in a few years, e.g. Quad OC is going to be there to the fifth. You're going to have a SIP. Everything's going to be quarterly anyway. Okay, so that is happening. Okay, probably in about 5 years. I got some slides on that in a minute. So anyway, this slide to me broke it down in a tabular form, telling when we might be in compliance with each individual, whether it be Quad O, Quad OA, Quad OB, and then at the down here, the state applied rules. So, and I got some more slides on that later. It's actually, when you think about it, to me, it's actually sort of fun watching all this stuff happen. It's a lot of work and a lot of rules, but there's a lot of stuff going on. The super emitters. And I am going in numerical sequence for the rule. Okay. And biggest thing is, and I have no slides on it, but if you're an aerial device, okay, basically where this is for flyovers, and satellites, right? That's what we're really talking about. And you can meet 100 kilograms. You get approved, you provide information to the EPA, and you're on a list that you can be somebody who is a reporter of a super emitter. Okay, so that way, if that entity that is approved does their thing, how they get paid, I don't know, right? But does their thing, and they see something over the level, at this point, 100 kilograms, right? You are then have to implement some type of initiative, corrective action, root cause analysis, et cetera. Let me go ahead next here. There's a statement in here. If you're an end user, you know, there's statements of that, much like when we had our compliance statements for DORs, signatures required by a responsible party. So there's more teeth in it like that in super emitter. If you do find a super emitter, you got 10 days to complete a root cause analysis. We all know what a root cause analysis is. Different over here because any refiners here? No, probably not. Okay. Your benzene fence line monitoring. When you find an action above a certain level, you have a plan, you have to implement a root cause analysis, has to do this. So same type of thing, you come up with a plan. That plan can involve any number of these, right? It could be OGI. Basically, you're going to find the leak, fix the leak. You got 10 days. It's a super emitter. You know, it's not when you get around to it. You take care of it. And you want to take care of it because super emitters are costing you money, right? If you can't get it repaired, you have to put a corrective action plan, similar to consent decrees or even the fence line monitoring. Same type of analysis, root cause analysis. We can't solve it. We've got a corrective action plan. That plan tell how you're going to solve this problem, whether it be shut down. Most super emitters might be coming from a pipeline, you know, rupture or something like that. Any of these things can be fixed normally through your normal operation. You have things in place to address these issues. If not, you know, there's probably a problem. And then there's reporting.
How does the company that finds the leak have to give us a notice in advance of the downside? Because typically we'll be done with it if it takes 30 or 40 days to already be cleaned up and done. Why do a root cause analysis for something that's already correct? I
didn't say that. If you haven't corrected it in 10 days, there's a time from being reported. If you haven't corrected it in 10 days, you have to go through a root cause analysis and how you're going to correct it.
So I guess how long will it take for them to tell us via EPA that we have a problem? Because there's a timing thing there. I mean, is it going to be like a month, 2 months, 3 months? And they're going to say it happened back 3 months ago. It's like doing a root cause analysis for something that happened 3 months ago.
This will not be Earthworks or different companies like that, where you know 6 months later we're sent a video of what we have in here, and then we're supposed to show how we fixed it. So, and you know, we had 2 OGI inspections since then, and nothing's showing up. And most of the time, it's you know methane slip from a compressor anyway, you know, or it could be something else. I'm just sort of exaggerating there, but yeah, this is immediate. This will be. I want to say 5 days, okay, is the requirement, but that may be in the alternative for continuous or the periodic. So there's a lot of things going through my head here. If it's not up there, chances are I didn't see it when I went through it. So, but my answer is it's going to be pretty immediate. It's a super emitter. So, on that. Feel free. You're only going to interrupt me for a second. I'm going to get back online. Don't wait till the end if you remember something, or make sure you jot it down. I got no problem jumping in and out like that. Okay. So when I talk about the super emitters, this is pretty much what I'm talking about. The satellites, and there's thousands. I say thousands. There's hundreds of them up there now. They're mapping everything from CO2 to methane to all sorts of other things. The ones in blue, I believe, is here for this one because I just pulled them off Google, right? Got another picture here. The different ones. The ones in blue are the future ones that are planned, right? Matter of fact, you may have seen a thing on LinkedIn, GHG sats, the things putting 2 or 3 more up in the first quarter. These are a large number. So the satellite and imaging part of our business, especially on the upstream, and I'm sure the density on downstream, that's things that are gonna be more visible. And most of their business models are working with you. I don't know how that business model works when you report to the customer. So we're gonna see how that shakes out. If you ever think about the business side of it. But anyway, these are some of the satellites available now. This also could be a fixed wing, I guess, or a larger floating balloon, like coming from China, whatever those things are. You know, just, it's an aerial kind of thing that can crawl and show that you can see 100 kilograms. Okay, this is like I said, through all this, I mean, I provide citations. In blue, I got citations out the side if I make it shorter. So it's too much information unless you want to check what I'm saying. As you start to say, okay, that's what I thought I heard, and cut and paste. So I spent a lot of time putting cross references on things like that. The main thing we want to talk about for the reciprocating compressors is now, if you are a CPF, which is Central Processing Facility, compressor station, or natural gas processing, there has to be an annual test done. Now, we remember the GHG testing we did on rod packing vents? How many of y'all familiar with that? Yeah, okay, yeah, it's sort of rhetorical. I'll move on. But yeah, it's what we've been having required to do the GHG testing, right? So from a business standpoint, we're now taking our compressor stations. We had our gas plants and our transmission, right? So now we're going to be going to our compressor stations or reciprocating compressors that are not on well sites. Well site compressors are exempt for this particular way. What it is a high flow sampler type of test, which I'll get into in just a second. And yeah, you go out there and screen. If you don't see it, if you don't see any emission, it can be assumed zero, much like the GHG. So it's almost identical to the GHG process, except that we have a procedure now. You can't just wing it and pull out your high flow sampler and go out there, calibrate it and go monitor. There's much like, if any of y'all been around in the late 80s, early 90s, when we first had to make our Method 21 calibration sheet, we had to set up a procedure to make sure our technicians got the right information down, we had drifts and all that stuff. So as we move forward with that, your companies are gonna need to make sure that we have a paperwork process to document. Oh, where go there? In case you don't know what a compressor is, and I do this when I train all the time, the rod packing vent is in here. That is your unloading valve, basically packing gland there, okay? So most of the time before they went to control, everything was a little P-trap up there, little candy cane, right? That vented the distance piece area. So as you're going through there, you feel like you can tell your technicians and people exactly where it is. Yeah, that's a candy cane, you know. There's a candy cane too, right? So it's in the distance piece area, in this area here, or not on the ends of these unloading valves. It's going to be on those heads right in the middle there. And typically they're manifold and may go to some type of control or down to a sump down here for your drains, because a lot of mist can come with that as well. Anyways, that's what it looks like. Here's where I start talking about what we have is in that reciprocating, I think it's 86B. Yeah, 86B talks about what you got to do. Then it's almost like an EPA method. They tell you the method. Okay, we used to just do the GHG method, just rock and roll through it, calibrate it, write down reading, and we're good. Now we have all sorts of procedures. You actually have to have a SOP, put in an appropriate monitoring plan, and here's the citation. So this is where you can check that type of stuff. So when we start setting up these SOP, or make sure your vendor that does the testing has those SOPs, you know, we need to make sure we have that, I guess. As a company, that's what I'm evaluating. Now, how do I go out if I'm gonna do this once it's done? Make sure that I'm not putting my company at exposure or compliance exposure, because if you're not following the rules, you didn't do the test. Anyway, this is something, if you're in that part there, you want to focus on these particular requirements or SOPs for the actual rod packing testing. And remember, you only, just like the GHG, you only have to test it. If you look at it with an OGI camera and it don't show up, it can be assumed zero. It's zero, move to the next one. Okay. If we do see some with the OGI camera, we have to implement some type of flow and concentration or high flow volume sampler, feed tube, and there's several methods in there, right? But here's the high volume sampling method. And just more on the reciprocating, it's new, right? All these procedures here, and there's the citations for each one, basically show making sure it works on a periodic basis, right? We have sampling procedures. We have to get a background, this for so minutes, that. So there's steps, which is little sections of your form for performing that work to make sure that we comply. Then there'll be some readings, how to calculate it, subtracting out background, not subtracting out background, 3 samples, 1 minute. So whoever's doing that in your company or your vendor, you know, you might want to look at the form. And once we have one form, it will be copied by everybody eventually, just like our method 21 calibration forms, right? And we'll know we're good. So it'll take an iterative process, but this is fairly new. I've been looking at it and I'm like, okay, I'm gonna find time to do that, right? Let me go back one more time, see if there's anything else on the floor.
If we do all that work, will it, take care of our W commitments that we have to do too?
Yes.
Okay, good. So
Yeah, just like the big guys in with federal and state rules.
Can we get a 2-for-1 deal?
Yes. If they follow that procedure. Now, what I expect, and I've talked to some other people, and please comment if you've heard different, is, well, they've refined, just like we got Phoenix Cake, which eventually will be migrated and everything. This will probably be in the revisions coming up for GHG. It makes sense, right? They want better quality data. Even in this one here, we can't use the old high flow sample. It's got to be a methane specific one, right? I commented against that. It's a DOC rule, and here we are having a methane specific. What about field gas compressors? So I talked about that, but whatever they come up with, we're going to do, right? So if it's a methane specific high flow sampler, I'm going to buy a methane specific high flow sampler. They don't allow you to go back in percentage and do some back counts based on percentage in the line. Okay. Yeah, this is a big deal as far as the changes in this rule. Other one's pretty much the same as the other one. First iteration. As I started moving into the fusion emissions part, my first thing is, okay, there was talk. I need to make sure I know what a fusion emission is. Okay. Well, we changed it. We had an old definition, we got a new one, right? When I compared the two, side by side, like I do here, it looks like pneumatics are leaks now. Remember, we had normal operations, not considered a fusion emission. That is not in there. At the same time, we're being pushed by state rules, federal rules, 0 emissions for pneumatics. So back to what I was saying, if you can go to compressed air, it's not an option gas plants. If you're near a grid, electrical, most of my customers are telling me, hey, they're already switching to compressed air, putting the headers up. So, but from a fusion standpoint, we don't get the, normal operation type of thing. So by not having it, we would assume that if your pneumatic controller is emitting, it's a leak, even though it might be operating right. So that's a great area. I commented on that as well. Okay, fusion emissions. The biggest, I'll say that a lot. The biggest change is, as opposed to just oil pads and compressor stations, we now have 4 types of oil pads and compressor stations. We got really, really small ones, okay? And then what's the small sites? Then we have single wellheads or small sites, which we have a definition I'll get to in a second. Wellhead only sites with greater than 2 wellheads. And they make it more complicated, don't they? I mean, we have 5 different iterations of it. Here's a definition of central production facility. That's important because if you take product from off-site, I'll say off the tank battery, send it to a central place, you have to do your reciprocating compressors. If you're all the typical tank battery where your 6-pack or 12-pack is all on the boundaries of the foundation, it's not a central processing facility. You don't have to implement a program because reciprocating compressors on well sites are exempt from those. So knowing your definition and and typically if you're operating the same, you're doing individuals batteries with 12 packs, 6 packs, whatever they are, 3 packs, or you're having a field where you're bringing it in. So you know how you operate if you have an exposure to a central production facility, and it's if you're bringing it from off boundary. Try to break this up into a thing. We have AVO inspections. That's also new. Required AVO inspections as well as a frequency of an OGI, right? So initial surveys over here, oh, I can point, I'm sorry. Over here, initial surveys are AVO or OGI, depending on one of those 5 particular stratifications. And then your periodic inspection, AVO frequency here. Instrument inspection, if you're a single wellhead or small site, you don't have a visual, you don't have an instrument inspection. Instrument, I'm saying OGI, right? And if you're small, basically you're semi-annual, then well sites went from semi-annual to quarterly. So if you're an upstream facility, you doubled your cost just on that aspect. You know, whether it's in-house or out-house, however you want to say it, or using contractors, functionally, what your work has doubled. There may be some efficiencies based on counts and things like that, but it's doubled. And then we got quarterly for CPFs and compressor stations. The time change between inspections, it's not codified for AVOs. So you could do an AVO on the 31st and an AVO on the 1st to comply with monthly. Can't do that for OGI inspections. OGI has a minimum time frame between inspections. How am I doing for time?
20 minutes left.
Okay. Then we have a repair and verification requirements. So one table is our inspection requirements. One table is our repair and verification, and then final repair. So I set this up into 3 tables because there's different time frames upstream. Okay. Here's our OVA first repair. If you find an OVA, AVO. OVA. Remember those that you're old enough to? Who's old enough to remember what OVA is? Yeah. Your visual inspection leaks is our first ones, 15 days after we find it. Okay, so we've got a first repair attempt. Final repair is 15 days after the first. That's a shift because if you've been in LDAR for years, the final repair wasn't a function of the first repair. In upstream, that time frame can change. If you got 30, like the old days, if you had 30 days to repair it, I would say don't repair it till the 30th day. So we got 60 days total to do it. You worked your system right. So here, those time frames are a function of the previous event, which is off the first event. So it can piggyback on each other. Same thing for instrument inspections. You know, within 30 days and 30 days after this attempt. Once again, so we could go 60. How you play with that's up to you, but that, yes, Mickey?
The rules don't provide any accommodation for continuous monitoring as a substitute for OGI, for the periodic OGI inspections.
You are preempting my. Yeah, no, I'm a thought leader. I mean, it may seem that, but I am following. Next one will be 98, which is alternatives. Okay, so yeah, no, I'll get to that, and I'll address that as deep as I can. We still know what that's. Here, let me get back to this. So here we are. So there's different repair requirements. The only change here from the previous one is actually our AVO inspections that's required. And then make sure you understand, you know, put things on DOR. Sometimes, and I've been in this for a long time, gas plants, and I'm not calling out, throwing any arrows at you, but they used to be real bad. Everything went on DOR in the 90s, right? Couldn't repair it, but on DOR. Try to be a little better than that. That's exposing you. So knowing when it's technically infeasible, knowing when a blow down maybe or things like that. So the effort should be to try to fix that within the time frame. You're getting 60 days, possibly 30, maybe plus 1, or whatever that adds up to be. We have more time. We know where our problems are. So my advice is always avoid delay or repair. May not be able to, but those are bad. Okay. Hey, Mickey. There we go. Okay. In this rule, we're providing some alternatives. In the previous rule, we talked about it in text, but it wasn't codified. They wanted comments, give me comments, give me comments. And if you ever went to the docket and just put in continuous and then search, there's a lot of comments. I think there were over 4 million, if somebody remembers, I can't remember the number, but the number of comments for this rule was crazy, all right? And you could actually search the docket on Word, you know, basically, huh?
Over 1 million.
Over 1 million, that's what it was? I'm a fisherman, I'm exaggerating. Next time, tell the story, 5 million. So basically, we have two options, a periodic and a continuous, okay? So we have two that could be codified as being an option not to do human-based OGI. Okay, they may change, right? Because each one of the, like if I'm an LDAR company, I'm saying, no, you don't need to do that. That's costing me money, right? If you're a periodic or inspection company that does flyovers and things like that, I'm saying, well, we don't need to, if we're doing this, we're good. You don't need to do your annual OGI, right? Because that makes our economics work out. Everybody has an angle in this world, right? But the big thing is, it's happening. Humans, just like we had kiosk. We didn't have kiosk at Walmart, Home Depot, etc., and we complained about it when we first got them. Now I get mad if a kiosk is closed. I mean, this is the way the world moves. I mean, we're going to be automating. I hate to make that prediction. I feel like that's the way things are moving. The technology is changing so fast. I've watched it in the last, since 2010, 5, whatever. I mean, I have to buy a new analyzer, something new every time, just replace, every time we went to Android, iOS, that, we used to do DOS-based. It's crazy. We don't have the life of our assets anymore. Okay, off the soapbox on that. So on the periodic side, if you are an end user, right, and you have somebody up there trying to, I'm going to use the word selling, whenever I'm pretty opinionated, I'll throw out some phrases like that. But if we have an alternative technology coming out there, you want to make sure you at least know what to expect. You have to write a plan. Your provider, whether it be a continuous or a periodic, will write 90% of that plan for you. Because they have to be approved, right? Okay, so don't worry about the plan. The plan will be as you integrate it in the years. It's going to be written by your provider, or you get another provider, or they're not ready. If they haven't read this and ready to write the plan on how their solution will solve your problem, well then maybe you need to think about it. My opinion, right? So it tells in here what the plan should include at a minimum. I'm not going to spend a lot of time on that. It's there. I have preferences. If you're considering a flyover satellite, you're going to have to comply with the monitoring plan requirements of the periodic requirements. However, they change based on all the comments when it finally happens. In my experience of 30 years, of which started out when, Han, in the early 90s, right? Once they proposed it, many changes. Once it's on paper, regulatory advocate of mine who works for a large company, he's not here. He said, once it's on paper, it's pretty much how it's going to be all the way to proposed and promulgated. There may be a few changes. Hopefully those changes are in Appendix K, if I have my opinion. So, but moving on, you must agree with the night. So these procedures, and then at the same time, I want to go over this. There's a frequency based on your resolution. What I mean by resolution, how well you can see it. They're listed there. If you can see, if you were quarterly, in this case, that's your well pads, compressor stations, and CPFs, okay? And you can meet this criteria, you can go according to these frequencies. And if you were semi-annual, same type of thing. I've done the math in my head. I didn't necessarily understand how I can go to 4 kilograms and go to monthly without that, but there's a method to their madness, right? To me, the point is, why do we have 5 stratifications? Pick 2. Pick 2. Pick 1, maybe pick 2 kilograms or less and above and higher. All these stratifications just, to me, make things more complicated. Either you can see low stuff or you can't. Okay, and then we have a frequency based on that. If you can only see 30 kilograms per hour, you're not going to be a solution, right? So I mean, to me, I commented on that. I said, that's ridiculous. Break it down to 2. Go ahead.
So your monitors are concentration based, basically. How do you get to a kilogram per hour?
Okay, what we do is we go out there and we put a mass flow controller on a cylinder. And then based on the flow rate and molecular weight for like pure methane, we know the kilograms per hour. And they use that because we really do concentration with OGI and imaging situations. So we've always, even with AWP, we've always gone to grams per hour. So I think that's what I process in my head. So you go out there, we know how big it is in mass.
So basically you set like a cylinder with a rotometer on it, and you just let that thing go out and you start to see.
Yeah, and if they're flying over and you turn it up to, you start out at 20 and they can see it, turn it down to 15, or, you know, you make that process. As long as they can resolve that level or those levels, then you can go to those frequencies. That's basically how they do it at MeTech too. They have mass flow controllers on them. So if you're going to a periodic thing, you know, you're gonna know where you are in here, and your vendor is gonna walk you through this process, right? What they don't do, okay, see, and there's a frequency on that. And we'll one, okay, yeah, next one. What are they fighting? Okay, the biggest thing if you go to comments is they're fighting right there. They saying, if we can resolve 1 kilogram or some number that they don't feel is valid to require a annual OGI, or excuse me, a complete OGI of the whole site, okay? Because they say their granularity can take you down to that piece of equipment. Good enough? Okay, I don't know. To me, it does away with OGI. I'm like, look, whatever, you know, what do I do? You know, however that shakes out. They commented one way. If it catches traction, the annual OGI may go away, and the cost analysis of moving to a periodic is there. One of the reasons they may have argued it, and we'll get to it in a second, is the continuous, when they find a issue, an action level above there, it's written a little different because it's continuous monitoring. There's no complete survey required. You just have a root cause analysis and you solve it, and it's shown by the continuous inspection of the leak, right? So that may have been what prompted them to really fight hard about that, because it needs to be economically viable. In the end, if it's a good solution, we got to be somewhere equal in cost, or we got to prove value and safety or something, or the magic spice that we have that makes that technology better than the other one.
3 minutes.
3 minutes. Okay, where am I? Doing good. Continuous, same type of thing. They will write the plan. The big thing on continuous is right here. Here's the things, the frequencies or the levels. Okay, so away from a plume, you have to be able to resolve a certain levels on rolling average. Interesting thing here. If you take 90 day, divide by 7, you get 12.1 something, or 12.1 something there. You divide that by 15 by 12.1, you get 1.25. So if you get a 7-day rolling average, you're going to have a 90 day. It's almost impossible because of the rolling average, right? Other than that, the other calculations go the same, and the calculated emission rate, once again, that will be in the plan. Process unit affected facilities. The big outtake here is Appendix K. It's going to, instead of using an AWP or method 21, Besser is now Appendix K. As an alternative, you may use method 21. And everything else is pretty much the same. Appendix K, what I've heard from industry, they're not going to do it. They're going to go back to method. Even if they were doing the AWP, they're going to go back to method 21. We'll see where that shakes out. You know, if there's any changes that make it less burdensome on them, but OGI. Okay, review. Overall, we have more frequent AO. There you go. Yeah, and more frequent OGI for upstream. Taking inspections to cradle to grade, because you remember there's a section in there which I skipped through that talks about well closure, right? You have to inspect to well closure. So cradle to grade. We have a super mineral rule. We'll see how this shakes out. Industry's fighting it hard. To me, it makes sense. You know, you got a big leak, find it. Rod packing vents annually. Besser is Appendix K for for NSPS. To me, the biggest impact to everyone will be Appendix K. And I am done. Oh, here's the thing. Over 1 million ONG sites, Google says, and they will all be regulated by 2028. So individual sites, not wells, sites. I'm done.
We have time for one question. Sorry. Is there anyone that has a last minute question? Okay, great. Thank you, Roy. If there's a sign-in sheet, please pass it around and sign it before you leave.
I knew I always go long.
You did good.
That was quick. Did it?
Yeah. No. Well, the thing is, I wanted the content so people could download it and use it if it's valuable. Okay. Yeah.
Yeah, I'll go ahead and get it for you.
Yeah, I'll go and take
Don't
care of it.
forget your.
Yeah, I was just going to inject it.
USB.
I was just going to inject it. Got you. But I was closing all your stuff, huh?
About to, but it's okay. I think it would have been fine. I think it does everything automatically anyways. You're good to go.
Ready?
Yeah. How'd it go?
I always get long-winded, but I think